What if you were deciding between multiple LLMs to perform a specific task, and you want to find the best one that meets your needs? Using an LLM benchmark can be an option. LLM benchmarks are standardized frameworks for assessing the performance of the LLMs. They supply a task that an LLM must accomplish, evaluate the model's performance based on a specific metric, and produce a score based on that metric. Models can be evaluated on their capabilities, which can include coding, translation, or text summarization. LLM benchmarks allow us to compare different models to determine the best model for a specific task. They also help us fine-tune the model to improve its performance. Now, let's go into the main components of an LLM benchmark. There are 3 main steps when it comes to executing an LLM benchmark. The first step is setting up and preparing the sample data. This is the data that we're actually going to use to test the LLM and evaluate its performance. This can include things such as text documents or coding problems or even math problems, depending on the use case. The second part is actually testing the LLM. Now we're going to test the LLM on the sample data, and we can use either a few shot, a 0 shot, or a fine-tuned approach, depending on the use case. This simply refers to how much data we're going to give the LLM, or how many labeled examples we're going to give the LLM before we test it. And now the last and third part, and arguably the most important, is scoring. We're going to use a metric to determine how the model's output differs or resembles the expected solution. Metrics that are commonly used include accuracy, which measures the number of correct predictions, recall, which measures the number of true positives, and perplexity. This measures how well a model predicts. Usually, one or more of these quantitative metrics are combined. And while this is not an exhaustive list, usually one or more of these quantitative metrics are combined in order to have a comprehensive and more thorough evaluation of the model's performance. Overall, using those metrics, we create a score from 0 to 100, which is the final evaluation score for this model. Now, let's look at applying what we've learned about benchmarks to an LLM example. Let's say that Joe, Susie, and Mark are 3 candidates who all want to join the track team. In order to join the track team, they must complete a 200-meter race, a 400-meter race, and an 800-meter race, and complete the race within a certain amount of time. These 3 scores will be aggregated to get their final score. Let's say that Joe is able to complete the 200-meter race, the 400-meter race, and the 800-meter, and he gets a score of 100 because he completed all 3 races. Susie was able to pass the 200-meter and the 400-meter, but not the 800, and got a score of 66. Unfortunately for Mark, he was able to pass the 200-meter, but not 400 or 800, and got a score of 33. Looking at these scores, we can see that based on this benchmark that we've set for the track team candidates, Joe is the best candidate for joining the track team. Now, let's look at applying what we've learned about benchmarks to an LLM example. Let's say that we have 3 LLMs, and we want to evaluate and compare all 3 of these LLMs on a science test. We want to determine which model is the best at answering questions on a specific science test, and we're going to use that as a benchmark. Let's say that we've prepared the data for this benchmark, and we've tested all these LLMs, and we're going to use accuracy as a metric. Accuracy, because it's quite easy to understand, is the number of correct problems answered. So the number of problems that were answered correctly on the test. Let's say that the first LLM, LLM1, has an accuracy of 90%. Because it's the only metric we're using, we'll just say that the score from 0 to 100 is 90. LLM2 has an accuracy of 70%, thus its score is 70. LLM3 has an accuracy of 30%, thus its score is 30. Based on these scores, which are based on the accuracy rate, we can conclude from the accuracy alone that LLM-1 is theoretically the best LLM for answering questions on this specific science test. However, LLM benchmarks can have some limitations. For one, they may not be able to accurately capture edge cases or very specific or unusual scenarios. In those sorts of cases, an LLM benchmark is actually not specific enough to accurately capture the problem that we are trying to solve. Number two, LLM benchmarks can actually be too specific and they can cause the model to overfit, which is not necessarily a reflection of how the model will perform on new or unseen data. And number three, due to the nature of LLM benchmarks, they have finite lifespans. If a model reaches the highest possible score, the benchmark itself will have to be altered. This will result in new benchmarks being developed as LLMs grow more advanced. Despite these limitations, LLM benchmarks are a good option for quickly evaluating different models on different types of tasks and fine-tuning models for improvement.